Hi, my name's Jacob Tucker, and today I'd like to talk about coastal engineering. Coastal engineering is a discipline of civil engineering that should be very important to all the residents of Hampton Roads. And the reason for this is that Hampton Roads is either slightly above, at, or in some cases below sea level. Now, this is the reason our streets flood when it rains, or the storm drains overflow when we get a really bad nor'easter. Now, these are all problems that you deal with when you move to a coastal city. And all the residents of the coastal city assume these risks when they move here. But a coastal engineer will assume the responsibility to mitigate these risks for the citizens of the coastal city. So let's dive in and see what it really is to be a coastal engineer. As with everything else in life, in order to truly know something, you have to know where it comes from. Coastal engineering is a relatively new concept to me. It never occurred to me that we had specialized engineers to deal with erosion, sediment control, and water control on America's coastlines. I guess I just didn't see the problem. But it turns out it's been in practice since the beginning of the United States. You think about that. That's over 200 years ago. In the late 1920s and early 30s, the first two professional organizations involving coastal engineering popped up: the American Shore and Beach Preservation Association and the Beach Erosion Control Board. Excuse me. Now, these organizations were founded to implement standards and procedures, much like our current organizations, the Department of Environmental Quality, Chesapeake Bay Preservation Act, and the State Water Control Board. All three of these organizations deal with the same issues that their predecessors did: erosion and sediment control, stormwater control, and coastal plain control. Now, prior to 1950, coastal engineering was really looked at in one way. You got to harden the beach. By this I mean riprap, which is large boulders, seawall, or a timber barrier. These all serve as energy dissipators, which means when the wave crashes into the energy dissipator, it slows the wave down before it actually gets to the sand and causes less erosion. Great idea. Works. We still use it to this day. In October of 1950, the first conference on coastal engineering was organized. It was held due to the vast expansion of science and engineering during World War II. And during this conference, they came up with a couple other really good ideas. Another one that we still use to this day is the beach nourishment program. Beach nourishment simply refers to replacing the sand that was eroded. You might notice the sand dunes throughout the year on our beaches. They simply push more sand over the erosion. And this works, but it's not a long-term fix. This is where a coastal engineer comes in. The coastal engineer can study the wave patterns, storm surge patterns, versus the amount of erosion that's happening real time. And with that data, they can decide we might need a seawall here, or let's look at option A or option B. And then they also they would design the seawall. How high does it need to be? How thick does it need to be? Can we use riprap instead? All right, now let's take a look at what coastal engineering actually is, what they do, and where they work. Coastal engineering is a multidisciplinary engineering field aimed at solving engineering problems related to the coast and ocean environments. Now that's your textbook definition. A coastal engineer simply is a civil engineer that's specialized in principles such as oceanography, geology, and other marine environmental factors. Now let's break that down just a little bit further. Oceanography in itself is the study of the physical and biological structures of the ocean. Now, of course, a coastal engineer would want to know about the physical structures of the ocean. They want to know, is the ocean floor strong enough to support the structure I'm going to place? Or how long will this structure last on this surface with the wave speed and the impact in this specific area of the ocean? Now, how about the biological aspects? Why would they want to know that? Maybe because when they place that foundation or when they place that seawall, it's going to have some impact on the life around it, the fish life, the plant life. So they need to know these things. Now, geology. Geology is the study of the physical structures of the earth. Now, that seems real clear to me. We want to know when this wave crashes into this cliff, how long is it going to last? What do I need to do to protect it? How do I keep my house from falling into the ocean? Makes perfect sense. Now, coastal engineers are found just about everywhere any other engineer is. They work for the federal government, the state government, and local governments, and they also can work in the private sector as consultants or designers. Now let's look at that specifically. In the private sector, maybe they work for an energy company that places wind turbines 60 or 70 miles offshore. So when they're placing that deep foundation to support that gigantic wind turbine, somebody's got to be able to tell them that the ocean current and the waves and the impacts or storm surges aren't going to affect this foundation, that our wind turbine is going to last. That's where your coastal engineer comes into play. I touched on it a little bit in previous slides, but I really wanted to look at what coastal engineers do in our time, in modern times. The largest role of coastal engineers in modern times is studying and mitigating the hydrodynamic impacts of waves, tides, storm surges, and their effects on the coastline. Now that goes back to when we were talking about beach erosion. Coastal engineers are looking at coastal cities to make sure that the infrastructure that has been placed over the years is going to continue to function and continue to stay in place in spite of coastal effects, in spite of tides and storm surges. So they might put in measures such as seawalls or riprap coverage or institute a beach renourishment program to ensure that this happens. Okay, so the Navy is a huge part of Hampton Roads, along with the Marine Corps and the Air Force and the Army and the Coast Guard, but specifically the Navy. Naval Station Norfolk is one of the largest naval stations, possibly the largest naval station in the world. That being said, they spend a lot of money in our economy and they provide us with a lot of jobs. So you might say they support our economy. Now, coastal engineers working for NAVFAC and the city of Norfolk, along with Army Corps of Engineers, have been working on this rising tide issue for a long time. They're trying to ensure that the infrastructure at Naval Station Norfolk doesn't disappear when sea levels rise. Now, just to touch on sea level rise real quick. According to the Virginia Institute of Marine Science, local sea levels here in Hampton Roads have risen an average of 5 millimeters per year since 2004. And the projections indicate that it's going to rise a foot by 2050. That's huge. You think our streets flood bad now. Wait till 2050. So we rely on coastal engineers to work on this problem so when 2050 hits, we have solutions. Okay, now that you've seen the data, don't panic. Coastal engineers, along with civil engineers and structural engineers, have been working on these issues for many, many years. In fact, engineers around the world constantly put their heads together to resolve these issues. You can see this reflected recently after Hurricane Katrina in New Orleans. They realized that the storm surge was too much for the measures they had in place, so they built bigger ones. They added height and thickness to the levees. They put diversion dikes in to give the water an alternate path. Or in Galveston, they've put seawalls in place after hurricanes in the early 1900s. See, the problem with this is that most of what we have learned comes from historic data. So something bad had to happen for us to realize we needed more intense measures. Now, it's the job of a coastal engineer to look at the historic data and to think outside the box to decide what we need now in this day and age. Now, besides violating environmental law, what do the bulldozers look like they're doing? They're pushing sand back up out of the water onto the beach. Probably a nourishment program that a coastal engineer came up with. See, coastal engineers are tasked with protecting our coastal infrastructure. And without them, and without the protections and measures they put in place, our infrastructure would be in danger of slipping into the ocean. Okay, so what is coastal engineering? Coastal engineering is a division or a discipline of civil engineering responsible for the organization, conceptual design and conceptual development, and the preservation of works solely on the shoreline. In order to perform these tasks, a coastal engineer has to manage shoreline erosion. They also have to improve navigation channels and harbors, and they have to protect against flooding brought on by storm surges or tides or seismic activity. Now, in the course of this work, a coastal engineer could be tasked with designing and implementing seawalls on a specific beach, or adding bulkheads to a neighborhood on a coastal city. They could also be part of an improved port development or mitigating flood measures in a city. Coastal engineers are everywhere, specifically on the coast, but everywhere, all across the world, and I think they are probably one of the most important parts of our coastal cities because they ensure that our infrastructure continues to function in spite of erosion, in spite of storm surges, and in spite of seismic activity. I would like to thank you for your attention. I hope you enjoyed the presentation, and also I'd like to apologize for the loss in video. I have a 4-year-old on my lap that can't keep her hands out of my face. The next few slides are my references. I hope